So in the given problem, we're having single switch and two positions over there. Okay, the switch is in position number 1 long enough to establish the steady state condition over there. The meaning for those things, if the switch is locating at the position number 1 for a long amount of time, it is reaches to the steady state condition. And then what they're saying here, at t equal to 0, the switch is moving to position number 1 to position number 2. When the switch is moving from one position to another position, there is a possibility of occurring transient conditions, switching characteristics of the circuit over there. Okay, so when the switch is moving from position number 1 to position number 2, when the switch is in the position number 1, there is a possibility of storing some amount of current through the inductor, because for applying DC voltage for long amount of time, the inductor behaving as a short circuit over there. Okay, when the switch is in position number 1, you have to determine the initial current that you have to carry over to the when the switch is moving to position number 2 over there. So in glance, we'll discuss what all things we're going to do. So first we're going to calculate at t less than 0 the corresponding initial current. So after that, the switch is moving to position number 1 to position 2. So consider the corresponding initial current and proceed the remaining things. Okay. So first thing, so as per the given statement, at t less than 0, the switch is in the position number 1. So I'm going to redraw the given circuit, RL transient circuit, 50 volt. This regarding to position 1. So we discussed already, if you are applying the corresponding DC voltage for long amount of time, the inductor will act as a short circuit over there. So based upon those things, I'm going to redraw to determine the initial current. Okay, so inductor is replaced by short circuit. Hope you understood. 25 ohm, this regarding to 50 volt, right? So follow the same current direction. So now apply the KVL. What will happen here? 50 plus 25, I equal to 0. 25 equal to minus 50, I equal to minus 2 ampere. This regarding to initial current. Now you have to consider this initial current when the switch is moving from position number 1 to position number 2. Okay, now I'm redraw those things. At t equal to 0, what will happen here? The switch is moving from position number 1 to position number 2. So this regarding to position number 2, this regarding to position number 1. At t equal to 0, the switch is moving from position 1 to position number 2. So you no need to bother about the corresponding 50 volt when the switch is moving to position number 2 over here. Okay, so follow the same direction. Okay, good. So by applying the KVL, when the switch is in the position number 2, this is the corresponding equation over there. So please don't confuse whether you can use I of t or I. Okay, so I of t is nothing but time varying current, or if you are representing with the small I, it is also denoting the same thing over there. Okay, so minus 100 equal to 25 I of t plus 0.01 d I of t by dt. So you know that the corresponding initial current, and apply Laplace transform over here. So minus 100 divided by s, 25 I of s plus 0.0. This regarding to L value, don't disturb those things. S into I of S minus I of 0. So this is regarding to initial current thing over there. So what's initial current value here? I of 0 equal to minus 2 ampere. So I calculated this thing when the switch is in the position number 1, right? Minus 100 divided by S equal to 25 I of S plus 0.01 S into I of S, minus into minus plus. So 25 I of S plus 0.01 S into I of S plus 0.2. So again you take it out, I of S. So how can I write this thing? 25 plus 0.01 S, take it this side, minus 0.02 minus 100 by S. Okay, by taking 0.01 is outside, 25 by 0.01 plus S into so I of S is nothing but S plus minus 2 minus 1000 minus 2S minus 10,000 divided by S. So how can I write this in I of S equal to minus 2S minus 10,000 by S into S plus 2,500. Okay, again apply the partial fraction followed by inverse Laplace transform and determine the I of t over there. Okay, so minus 2S minus 10,000 divided by S into S plus 2,500, A by S plus B by S plus 2,500. So how can you write this thing here? LCM is nothing but same as the denominator in the given function, A into plus BS cancel. So remaining minus 2S A into S plus 2,500 plus BS. So what are the possibilities here?
3.
S equal to 0 in equation number 1. So minus 10,000 equal to A into 2,500. So what's A value here? So another possibility, S plus 2,500 equal to 0. S equal to minus 2,500 in equation number 1. 5,000 minus 10,000 B into minus 2,500. So after simplification, so B equal to minus 50 by minus 25 is nothing but 2. So B value 2, A value minus 4, I of S equal to A by S plus B. So after taking the inverse Laplace transform, apply inverse Laplace transform. So I of t equal to minus 4 plus 2 e power so you can cross check your answer whether it is correct or wrong, which is simple thing. For example, I'm saying okay, t equal to 0. So I of 0 equal to minus 4 plus 2 e to the 0 minus 4 plus 2 minus 2 ampere. This regarding to initial current, correct? So you can verify, you can cross check your answer by replacing t equal to 0 what you calculated in previously, right?